Alright, let's talk about the difference, or the information that we communicate using significant digits and figures. Because we're not always there to talk face-to-face about, okay, I know this for sure and I'm estimating this, but we can actually communicate it by the numbers that we use. So remember from the example today, there's a difference between if I am measuring something, let's say this is in meters, we did centimeters today, but let's work with meters, and I'm estimating a certain length to be 50.4 meters, and that's different if I actually have markings that indicate tenths of a meter, and I can see that that length is exactly 50.4 meters. Alright, so I would say 50.40 to indicate that this is not 50.39 or 50.41. I know that it is exactly 50.4. And remember, whatever markings I have, that's the 50.4, I need to estimate the next digit over. Right, so over here I had 50 and 51 marked, which means I can indicate the next digit over, because I know that it's not on 50 and it's not on 51, it's somewhere in between. Here, I would need to indicate whether it is on 0.4, right, which is, here's 0.5, and here's 0.4. Normally, given this kind of a scale, I would need to indicate 0.4 what? If it were somewhere in between 0.4 and 0.5. Therefore, if it is exactly on 0.4, I need to indicate that as well. Okay, so this has 1, 2, 3 significant figures that carry information. Figures are digits. This one has 4 significant digits. Okay, including the one that I am making my best guess at. And this is all part of being accurate and honest in science about what I know and what I don't know. Now, why is it important to keep track of these, and how do we tell what figures are significant or not? Well, since this is the information I know, 3 significant digits, or 4, we'll deal with these separately, that level of precision and honesty should not change if I simply convert my units. So for example, if I turn this into kilometers, alright, so a meter is 1,000th of a kilometer, so this would be 0.0504 kilometers. Alright, it's probably clear when you look at this number. I just count the number of digits I have. Well, what about this? So in fact, if I have a number that is to the right of a decimal point, the zeros leading up to that number, these are not significant. Basically, any number that is non-zero is significant. The only reason it's non-zero is that it indicates some sort of measurement. So my 5, my 4, any zeros in between my number, it should be clear that that's part of my measurement. I measured 50.4. But zeros that are not within my number, so for example before, these are pretty much just placeholders. They came here because I expressed something in kilometers, and so I need to indicate this is actually 504 10,000th of a kilometer. So these are not significant. Again, any normal number is significant, but zeros may or may not be. The zero in between numbers always is. The zeros that come before, in order to indicate place value of my significant numbers, these are not significant. These will change if I change my units. You know, if I go to megameters, I'll have, 0.0000504. Alright, so these are not significant. And these, again, these are my 3 significant digits.